All right. So name this compound. HCl. So what do you think? Hydrogen monochloride? If we treat it as a covalent, I mean, HCl, this is going to be kind of right on the verge between ionic and covalent, right? So hydrogen monochloride, or do we maybe treat it as a full ionic and just do hydrogen chloride? I don't know. Which one do we do? Well, the answer is neither of those. They are both wrong. The name for this compound is hydrochloric acid. This, my friends, is stomach acid, hydrochloric acid. So the next thing we're going to be talking about is naming acids. And if I look through here, okay, I notice that there are a whole bunch of different types of acids, just kind of like there are a whole bunch of different types of ionic compounds. These ones here are what we call binary acids. And for identifiers, I'll just use BA. Okay, and if I look at binary acids, I see that they all have this prefix hydro. Okay, so it's hydro, and then the root of the element name, and then ic. Now, one of the things that people tend to get confused about is the hydro thing. Okay, this doesn't mean hydrogen. Okay, this has to do with the fact that acids behave acidically when they're dissolved in water. Okay, so this has more to do with the fact that there's going to be water present. And this hydro is unique to binary acids. It's how you identify something as a binary acid from the name. Okay, so that's binary acids. Now, if you look at the rest of them, the rest of these are polyatomic acids because they have polyatomic anions. Now, these would get the identifier PA. All right, and the rule for these, you'll notice that they have the name and then they have an ending. So it's like the root and the ending. And the ending actually comes from, it's related to the ending of the polyatomic ion. So for example, if the polyatomic ion ends in ATE, the ending that you'd use in an acid is IC. And if the name of the ending, or if the ending of the polyatomic ion comes from ITE, the name of the acid would end in OUS. Okay, so for example, nitrate would go to nitric acid, nitrite would go to nitrous acid. So there you go, nitric acid, nitrous acid. Okay, now one of the things that you'll also notice about acids is that they all start with hydrogen, and that's how I'm going to want you to identify them. There's some more stuff that's going on, but I want you to identify them with the presence of hydrogen in front. That'll just make it really easy. Now the only one that's a little weird there is this one, acetic acid. Okay, another way, there are actually two ways that you can write acetic acid. I'm going to jump up here. So you can write it this way, But the way that I'm going to write it is either this, okay, or HC2H3O2. Okay? These are both acceptable. This one gives an idea to the structure. This one is just kind of the simplest formula. Okay? Acetic acid is CH. There's CH, C, double bond O, O, H. Okay? This proton right here, the single one, this is the one that makes this an acid. Okay? These ones over here, they don't. So in this compound, this is called a structural formula. It gives an idea of the structure. In this structural formula, they put the H over here next to the oxygen that it's on. But I like to put it in front so that you remember that it's an acid. Okay? So just keep those things straight. So let's do a couple examples here. Okay? Name to formula. You have to identify the type of compound. Okay? Well, I know that this is an acid, so it's either binary acid or polyatomic ion, or polyatomic acid. Binary acids always have the prefix hydro. This does not, which means it's a polyatomic acid. Okay? Write the name of the polyatomic ion. Really what I'm looking for here is just the anion. Okay? For a binary acid, it would just be an anion. Okay? It would be a monatomic anion. So here, write the name of the polyatomic ion. So this is chloric, and I know that 8 goes to ic, which means I can go the other way. It goes to 8. So this would be chlorate. Okay? So now I go to my polyatomic ion chart. I find chlorate, and I write the charge balance equation. So chlorate is ClO3 minus. Now, you'll notice that the cation's never named in here. Well, this is an acid. Acids always have H plus as the cation. So now I can write the formula. Okay, this is charge balance as it is. So this is just HClO3. Okay. Formula to name, just the reverse of that process. Okay, so here we have HNO2. This is a polyatomic acid. Okay, I can tell because it's not a binary acid. Write the charge balance equation. That's H plus, which means that this NO2 must have a charge of -1 because there's only one hydrogen ion. Now, I go to the charge -1. I find NO2. That's nitrite. Okay. I know that ite goes to OUS. So this is nitrous acid. Okay. That is naming acids.